Hello, today we're going to review for the end of year test. I want to go through kind of what some of the questions are going to look like. Let's go back and review some of the things we did way back at the beginning of the year, and let's remind ourselves how we put some of these answers. This review will take the whole period, and you don't need to take notes. If you're going to review them later, that's fine. You cannot use notes on the end of year test, even if it's the alternative test. So please pay attention and do your best to just follow along and remind yourself how to do these. All right, are we all set? Let's go. Number 1, a function is shown. So here we have a function. Remember, f of x is just like y equals, where f is the name of the function and x is what is being replaced. Okay, so in this case, we see we're going to be graphing. That means this is the same thing as y equals. We don't need to worry about f of x, it's just y equals. We need to have this in some format that we can graph. That's easy enough to do. What's 1/2 times x? Let's solve what we can do. We have negative 1/2 x, and this is y equals, because this is y equals. So negative 1/2 x, negative 1/2 times 4 is negative 2 plus 5. Now let's combine what we can right there. We can combine those two, and we get y equals negative 1/2 x. Negative 2 plus 5 is plus 3. And now look, we're in y equals mx and plus b, where m is the slope and b is the y-intercept. So with all of that in mind, let's add a point if we can, or let's do what we need to do. Right now we can add our y-intercept. It's plus 3. So I'm going to add a point right here at positive 3. Right there. From there, I know I got to go down 1 over 2. So down 1 and positive 2. So I'm going to add another point right there. Down 1, positive 2. And this is our line. Once we have 2 points, we can easily draw an arrow between them. Now you don't have to keep the arrow going. Just connect the 2 points and you're done. On Alex, that arrow will continue on forever. On the Sage, it will just connect the 2 dots just like this, and that's perfectly okay. So don't worry about making the arrow go too much bigger. Just solve so that you can get y equals mx plus b, and then just connect the dots once you get there. Number 2, a linear function is shown. So here's our function. We know it's linear. Linear function, which means it makes a straight line. Now this straight line, we can see there's a slope and there's a y-intercept. Create a linear function, g of x, such that f of x equals g of x has exactly one solution. That means that we want f of x and g of x to cross in one point. That's what it means to have one solution. So they're going to cross at one location. Is there anything I can do to make them cross? What points can I see from this one? Well, there's an easy point to get, and that is our y-intercept. We know that this one has to cross at negative 3. So our g of x also has to cross at negative 3. Now we got a point where they cross. They cross right at 0, negative 3. In order to make sure they're not parallel lines or anything, we're just going to make that a positive slope. So g of x equals 5 over 2x minus 3. Now, why did I make that a positive slope? Well, a negative slope is going to go down like this. So when I make it a positive slope, it's going to start going up. Now I know that those 2 points will cross right there. Those two functions will cross right there in one spot, or at one solution, exactly one spot. So let's go ahead and type in what we know. Okay, we want this to be 5 over, let's clear the text here so it's a little easier. We have a fraction, so we're going to push the fraction. 5, click here, over 2, x, and then we said minus 3. Had to be the same y-intercept as right here. So minus 3. So here's our equation that will cross this one in only one location. Where does it cross it? It crosses it at y equals negative 3. But what is our x? Well, if we remember, our x-intercept, or excuse me, our y-intercept is right here, where x is 0. So this would be 0, comma 3, or in our case, we're crossing down here, 0, comma negative 3. Either way, our x number is at 0, and they both will cross right there. So we can say, hey, x is 0. What is y? If it were asking for y, y would be negative 3. Any questions on this? Number 2. Number 3, a square is rotated about its center. Select all of the angles of rotation that will map the square onto itself. So if we have a square, let's see if I can draw a decent square. If we have a square, and here's the point of center. What the rotation, square's rotated about its center, so it's like we put a pin in here and then just rotate the whole thing around. Okay? We're just rotating the whole thing. Select all of the angles of rotation that will map the square onto itself. Now, map the square onto itself. What does map onto itself mean? It just means it will stay, or it will look exactly as it does right now. Map onto itself means all the lines will line up perfectly. So if I rotate this 90 degrees, so I take this corner and rotate it there, that's 90 degrees, it will look exactly the same. So I know 90 degree turn will look exactly the same. Now if I rotated another 90 degrees, it will look the same again. So 180. 90 plus 90 is 180. And another 90 degrees, what's 180 plus 90? That's 270. As you can see, and then 360 would be the last one. As you can see, every 90 degrees it maps onto itself. So that's all that maps onto itself means, is that it looks exactly the same as when you started. And here we have, it'll do those 3 times. 90 degrees, 180 degrees, and 270, it will look exactly the same. The gravitational potential energy, blah, 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 we don't even know. We just know, hey, the squiggle's something or other. Okay, don't let the fancy names throw you. The gravitational potential energy of an object is given by the formula P equals mgh. We need to know that one. What is the equation that correctly solves for height? So we need the answer to be h equals. So we need to get this h by itself. If we have P equals mgh, remember these are both times. When the letter's right next to itself, it's times. Well, we don't want this m times g times h, so we're going to divide by whatever we don't want. mg. We're going to divide by both of those, divided by mg. And that gives us p over mg, which would be this one right here, c. Now, what if we forget to do it all at once? What if we need to do it separate? That's okay. We would have P equals mgh. Well, let's divide by g. And we see that the g's cancel each other out. Remember, if it's the same on top and on bottom, they go away. They cancel each other out. So what else do I have to divide by? Divide by m. So that'll go away. So P divided by m, we still get the gm, or mg. Now, what if we had something slightly different than this? Let's just say, for example, we had P equals m plus gh. And I'm just making this one up. And we're trying to solve for h. Well, what we do is we always take everything that's connected through multiplication and division, put it in the box, and get rid of everything outside the box using addition or subtraction. So now we have P minus m equals, and this goes away, and we're left with gh. So when we're solving for a letter or an equation, you always do addition, subtraction first. Then we clear the multiplication. So we're going to divide by g, and it would be this, because the g's would cancel each other out. So always do addition, subtraction first, and then anything that's left. But in this case, all we have to do is divide both sides by mg, and we're good. Another way to remember that is you've got your order of operations. P, please excuse my dear Aunt Sally. When you're solving an expression, does not have an equal sign. Okay, when you're solving an expression, you go that way. In other words, you're just simplifying. Okay, if you're simplifying an expression. Now, if you're solving an equation, that's the one with the equal sign. Then you go backwards. You always do subtraction, addition first, then division, multiplication, then any exponents, then any parentheses. Okay, so you always go backwards at that point. So hopefully that helps you get started on that one. Yesenia records the ages of 9 friends. A box plot of her data is shown. So we have a box plot right here. Click the above the number line to create a dot plot that could represent Yesenia's data set. So we have a box plot. We know that one of our numbers is 7. So we got to put a dot on 7. We know that one of our numbers is 17. So we've got to put a dot on 17. That's what we know for sure, but we could easily get those 5 more numbers. We've got 9, 13, and 14. But will this give me the answer? No, it's only 5 numbers. And we need how many? We need 9 friends. So we need 9 numbers. Well, and not only that, this won't even give me the right box plot because we need 2 more right there. Remember, you've got to have this be the middle number of the lower half. This has to be the middle number of all of them, and this has to be the middle number of the upper half. So we have 7, 9. If I do 13, 13, and 13, and then 17, notice I put 13 three times. What's my middle number? Oh, and I forgot 14. Sorry. 14 is right here, right? So what's my middle number? Well, if I go back 3 and 3, that leaves this as my middle number, 13. So good, that's where my median is, right here at 13. Perfect. Now if I ignore the median, what's my middle number now? 14, which is exactly what my Q3 should be. And 9 is my other, that's Q1. And minimum maximum. So that's why I put the median 3 times. It just immediately sets it up just fine. How many numbers do we have? We have 1, 2, 3, 4, 5, 6, 7. So we need to add 2 more numbers. Whatever 2 numbers we add has to be 1 on top, 1 on bottom. So one above, 1 below, but it has to keep 9 in the middle. So what about if I add another 9? Now what's my middle number? I have 7, 9, 9, 13, so it'd be right here in the middle. What's right in the middle of 9 and 9? That would be 9. So that keeps my Q1 as 9. And if I do the same thing here, if I just add another 14 right here, so I'm going to add another 14 right here, what would that do? Now my middle number is right here between these two. And what's right between 14 and 14? Well, 14. And that's what it has to be. It has to be 14. So here we go. Now would these numbers give me this box plot? Absolutely they would. So just remember, your median has to stay in the middle. Whatever numbers you come up with, your median has to always be in the middle. Your Q1 always has to be in the middle of the bottom half, and your Q3 always has to be in the middle of the upper half, and your maximum minimum always have to be there as well. Hopefully this helps you get started with this. The best thing to do is to write down the 5 numbers and then start adding numbers and making sure your medians fit where they need to be. Once you find that, then you'll do just fine. Number 6, we're given an equation and we want to find out a line that's perpendicular, so we need to remember that, perpendicular and going through the point -2, 8. Well, we know we're going to have a slope and we know we're going to have a point, so we would use the point slope form, which is y minus y equals m times x minus x, where we plug in this y, the second y, second x, second y, second x, and the slope. So let's go ahead and go through this. First, we got to get this in y equals mx plus b, where we would then know the slope, and well, we don't care about the y-intercept. We just need to find the slope. So I'm gonna swap these two and make it 2y equals 2/3 x plus 14. From here, I've got the slope almost there, but I have to divide everything by 2. So divided by 2, divided by 2. That gets rid of this, giving me y equals, and what do I have? I have 2/3 divided by 2. If I don't know how to do that in my head, that's fine. Pull out the calculator, reset it, second plus 712, so that it's all ready to go. Now I have 2/3. It's a fraction, so it goes inside parentheses. 2/3 divided by 2, enter, and I get that. So I'm just going to hit math, enter, enter, and I get 1/3. 1/3 x. And 14 divided by 2 is 7, so plus 7. So here's my equation simplified down. That's the same equation. Now I need to be perpendicular to that slope. Perpendicular, hopefully you can remember, is the negative inverse. So inverse means we're going to flip it upside down, and it becomes 3/1. And instead of positive, we're going to have it be negative. So we just take that 3, put it on top, the 1 on bottom, and flip the sign from negative to positive or positive to negative. So here I've got negative 3/1. Well, we don't need to put the over 1 part. Anything divided by 1 is itself. So we know that this has to be y equals negative 3x. But we need to find out what my y-intercept is. So I'm just going to write that down here. Y equals negative 3x. How do we find the y-intercept? Well, we plug everything in to this equation right here, giving me y minus, what's my y? 8. There's my y. So y minus 8 equals, what's my slope? Slope is negative 3. Negative 3 times x minus, and my x is negative 2. That's not an exponent. Sorry, I wrote it a little too high. So let's simplify what we can. Y minus 8 equals, let's distribute, negative 3x. And negative negative, or minus a negative, is plus. What's plus positive 2? Negative 3 times 2 is negative 6. Now I'm going to plus 8 to both sides. And I get y equals negative 3x plus 2. This line is completely perpendicular to that line. So I know, let's clear this out so I can put my answer. I know that my answer is going to be y equals, and with the y equals, we're going to have negative 3x, negative 3x plus 2. Plus 2. So that's my answer. That line, or those two lines, are perfectly perpendicular to each other, and this line will go right through this point. Question number 7 gives us a system of equations. It's been a while since we've done systems, so how can we find what this system represents? There's lots of different ways. One of the easiest ways for this particular one is to just find out what d equals. I'm going to clear this fraction. And why would that be the easiest? Well, because it's already mostly solved for d. Remember, there's several ways to do it. There's elimination, where you can add them together to eliminate one or the other, but if we add these together, they're all kind of mixed up anyway, so it's not really going to help us. There's substitution, which is taking one of them, like this case, d equals, and the rest, and then just plugging that in for d. And that's what I'm going to try to do now. So let's do that. Seven over 2d equals 41 minus 22c. All I did was just rewrite the problem. Okay, that's a c. All I did was rewrite the problem. Now, I don't like that fraction there. There's always a way to get rid of a fraction. That's to multiply everything times the denominator. So we're going to do that. That gets rid of the denominator. 7d equals 82 minus 44c. Great. Now I'm just going to divide by 7, divide by 7, divide by 7. And that gets rid of this. That gives me d equals, and just to make sure that that's simplified, the more simple it is, the more simplified, the easier it is. I'll just pull out the calculator and do 82 divided by 7 equals, and then math, enter, enter. 82 divided by 7, yep, that's simplified. And we're going to do the same thing, 44 divided by 7, and math, enter, enter, and that is also simplified. So it seems kind of ugly, but that's simply because they're fractions, which is fine. We can deal with fractions just fine. So we have d equals 88 or 82 over 7 minus 44 over 7c. This is d right here. D is that. So we're going to take that and plug it right in there for d. And that would give me 4c plus 2 times d. What is d? (82 over 7 minus 44 over 7), I just copied here, c, equals 11. So all we did was just copy what d equals, and now let's simplify. What's 2 times that? I don't even want to do that in my head. So let's clear a little bit of space here. And I'm going to take 82 over 7. Remember, it's a fraction, so put it in parentheses. 82 divided by 7 times 2 equals, and then math, enter, enter, 164 over 7. So I have 4c plus, that's a plus, 164 over 7. Now I'm going to do the same thing with the negative 44 over c. Negative 44, again, it's a fraction. So negative 44 over 7 times 2 equals, math, enter, enter, negative 88 over 7. Negative 88 over 7. C equals 11. Okay, now there's a big chunk here that I don't like. This right here is nuts with the fraction. There's a quick way to get rid of a fraction. To get rid of a fraction, we multiply everything times the denominator. 4 times 7 is 28c plus, the 7s are going to cancel each other out. So we get 164. Again, the 7s are going to cancel each other out. Minus 88c equals 77. We're dealing with big numbers, but that's all right. That's what our calculator is for. So using the calculator, let's simplify as much as we can. I've got a positive 28c minus an 88c. So how many c's do I have? I have negative 60 c's. So negative 60c, that gets rid of this 28 and this negative 88. Now I have plus 164, that won't simplify with anything, equals 77. I'm solving for c, so I'm going to minus 164 from both sides. And again, don't do it in your head. Minus, or let's clear that. 77 minus 164 equals negative 87. So I have negative 60c equals negative 87 because those cancel out. Now I'm going to divide that by negative 60. And you can see why we're just dividing by negative 60, dividing by negative 60, and our answer is 1.45. Math, enter, enter, 29 over 20. And that gives it to us simplified. 29 over 20. Let me double check that, make sure I had it right. Yep, 29 over 20. So now we know what, and what is this? We're solving for c. Great. So with that in mind, c is, oh, and it wants a decimal. See, there's no fraction down here. If it doesn't even get us a fraction, then we pull the calculator out and find the decimal. In this case, it's 1.45. So that would go right here, 1.45. Okay. And D, well, if we know what C is 1.45, let's plug it in right here. Let's clear some of this out. 1.45. So 4C, actually, I cleared it out too quick. I can just plug it in right there with my calculator. I don't even have to do work. Fraction, 82 divided by 7 minus fraction, fraction 44 divided by 7 times, and we figured it was 1.45, 1.45, enter. Let it do all the work. You don't do any of it. It's 2.6. So just let the calculator, plug it all in, let the calculator do all the fractions. You don't need to be afraid of fractions. So there's our answers. And you're going to get decimals, and that's perfectly okay. Select all the relations where y is a function of x. In other words, function of x equals blah, 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 blah. We want to know when y is a function. In other words, the vertical line test. We just want to know, is it a function? That's what it's asking. Is it a function? So here, there's only one answer, one answer, one answer, one answer, one answer. Yes, that's a function. Next one. Is this a function? I see two of them right here. That means it is not a function. If you get two answers, or if the vertical line test fails, it is not a function. And again, we're just asking, is y a function of x? Or is it a function? Two answers for number 2, two answers for 4, two answers for 6. That means this is not a function. there can only be one answer for every x. One output for every input. One answer for every question. One answer, one answer, one answer, one answer. In other words, one arrow, one arrow. Now, notice right here, these two go to the same number. It doesn't matter. As long as there's only one answer for 3 and one answer for 5, that's perfectly okay. Now, if I do the vertical line test here, no matter where I draw the vertical line, I will only hit that function once. So that makes it a function. However, right down here, if I do a vertical line, notice I'm hitting the answer twice, or the black line's the function twice. If there's ever more than one answer, or the vertical line test hits more than one line, it is not a function. So that's all that type of question is asking. Is it a function? The triangle is shown on the coordinate grid. Use the connect line tool to draw the triangle after transforming following the rule. This one you probably haven't gone over yet, but it's extremely simple. What am I doing with all the x's? All the x's are -4. So here is my x. What x value is it? It's 2. So I know it's going to do -4. 1, 2, 3, 4. Okay, all my x's are -4. Now, without the drawing, it's still extremely easy. And that's actually probably the easiest way to do it. What's my point here? It's 2, -2. What's my point here? It would be 5 and 2. So 5, I'm going to put it down here, and 2. And what's my coordinate here? 6, -3. What am I doing with all of these? I'm taking x -4, so -4, -4, -4, and I'm plussing 3 to y. +3, +3, and +3. Perfect. So what are my new points? 2 minus 4 is -2, comma, 2 minus 3, or -2 plus 3, excuse me, -2 plus 3 is 1. So there's 1 point. 5 minus 4 is 1. 2 plus 3 is 5. There's my next point. 6 minus 4 is 2. -3 plus 3 is 0. There's my next point. So now we can add our points. So we're going to click Add Point. And where's our first point? -2, 1. So -2, 1. Where's our next point? 1, 5. So 1, 5. And our last point is 2, 0. And I'm just going to connect all those with a line. I'm going to connect that dot with that dot with that one, and that one with that one. Just click each dot and draw your line with the connect line tool. And that is that drawn with that rule, that transformation rule. All we did was -4 plus 3. X -4, y plus 3. So hopefully that helps you get through that kind of a problem. It's actually very easy. In this case, number 10 says, a scientist is studying the population of an ancient civilization. She found that at one point the population was 5,000. The population doubled every decade after that. Create an equation that can be used to find after how many decades the population reached 640,000. We're dealing with an exponential growth. We're starting with something. Remember, that's a sub 1 times the ratio raised to the n minus 1. Now, this is what our answer is going to look like. Something like this, but we need an equation. So this is going to be, what's this going to equal? It's going to equal our population. So what is our a sub 1? Where are we starting? At one point, it is 5,000. So we're just going to assume that's our starting point. What's our ratio? It is doubling every decade, so times 2. And then, how many decades? Well, instead of n, it wants us to use d. So d minus 1. There's our equation, but we want to know when all of that equals 640. So we're going to say, okay, 640, and all we need is the equation. See right there, create an equation. Don't try to solve it. 640,000 equals 5,000 times, and I'm just going to put it in parentheses, times 2 raised to the d minus 1. Right there. And that's the equation to find out. So just remember, we know what we want it to equal. We want it to equal that, 640,000. And we know what the equation is. It's 5,000 times 2, a sub 1 times ratio raised to the n minus 1, only instead of n, it wants d minus 1. And that's all it's asking. Don't let all the fancy words in the story problem confuse you. Plug in what you already know and just go from there. Juan collects data on the number of hot dogs sold at a hot dog stand each hour, one day, and the number of cars that drive by the stand in that same hour. His data is shown on the table. So we have the number of hot dogs sold and the number of cars. Based on his data, which conclusion can one make? Now remember, there's two things. There's causation and there's correlation. Or in this case, the answers are given to us in associated or causes. Associated means there's some kind of trend. We may or may not know what it is, but as X changes, Y changes as well. Causes means that it's a very closely correlated thing, and it's obviously that one thing is causing the other thing to happen. So first, let's see if there's even an association. An increase in cars is associated. So as cars increase, so this is higher. So we start low, we get low. As we get higher, it starts to get higher. And we keep checking, and it keeps going. So as cars go by, he is in fact selling more. So that means that there is an association with an increase. And where there's an association, there could be a cause. So it could be either B or D. But we do not see any association with decrease. Well, what does that mean? Let's think logically. Does the number of cars cause him to sell more hot dogs? I would say yes. It increases and causes the increase of hot dog sales. If it were like the number of cats that were counted in a store across town, then it wouldn't really matter. Then there might be an association, but one thing is for sure not causing the other thing to happen. All corresponding sides and angles of triangle RST and DEF are congruent. Select all the statements that must be true. All right, well, let's just, on our scratch paper, let's just draw it. We have R, S, T. Doesn't have to be to scale, you're just sketching it. Doesn't even have to be a good triangle. Look at mine. RST and angle DEF DEF have to be congruent. Well, let's look at side RS. RS comes first. So what two letters represent that? DE. So I know this side and this side are congruent. Perfect. Now we know that ST. Well, ST come last. ST is congruent with EF. But they may or may not be congruent with RS and DE. So we're going to put two lines just to keep them separate, because we don't know that they're equilateral triangles. And TR are my two outside TR, so FD. FD. And we're going to put 3 hash marks there because we don't know again. Great. Now we have all of those. Now let's mark the angles congruent too. Angle R is congruent with angle D. R, D. I'm going to put one little arc there. Angle S is congruent with angle E. So S and E. We're going to put 2 arcs there to show that those are congruent. And T and F are congruent. So we're going to put 3. Just like that. So now we've got them marked. It's a lot of mess, but at least we have something to look at. The first one, there's a reflection that maps RS to DE. RS to DE. We see that they are in fact the same line, they're congruent with each other. So that could very well be true. Okay, because they're the same, which means they can map onto each other. If you remember, mapping onto each other means that they'll line up perfectly. And if they're congruent with each other, there's a way to get them to map onto each other. There is a dilation that maps RST to DEF. Now, dilation means it gets bigger or smaller, and that can't be. Remember, if they're congruent, they're the same size, same shape, which means dilations won't map it onto each other. It will make them so they're no longer congruent. There's a translation followed by a rotation that maps RT to DF. RT and DF are the same line. So we can do a translation and a rotation. It may be a complete rotation, maybe 180 degrees, maybe 360 degrees, but there is a rotation and there is a translation that will get there. What we're looking for, congruent must have rigid transformations. Rigid meaning it doesn't change the shape and it doesn't change the size. Everything else will map it onto itself as long as the sides are congruent. There's a sequence of transformations that maps RST to DEF. So RST to DEF. And there is. Transformations could be rotations, could be a whole bunch of things. Doesn't have to be resizing. And there's not necessarily a sequence of rigid motions that maps RST to DEF. If they are congruent, then rigid motions will always map them onto themselves. So that last one cannot be true. So remember, reflections means it flips over. It's like looking at it in a mirror. It's backwards. But it's a rigid transformation. It doesn't change the shape or the size. Dilation makes it bigger or smaller. That does change the shape and the size, or it changes the size. So it's not rigid, which means it can't work with congruent. Translation means it slides it without rotating it or flipping it over. So it just slides it like a card on the table. And a sequence can mean any of those above. Number 13. This type of question says an equation is shown. Drag the statement to the box to justify each step. So we're doing a proof, basically. 4a, yada, 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 is all given. Now a bracket is the same thing as parentheses. We talked about that a little bit. A bracket and parentheses are the same thing. So what's happening here? We're multiplying the 4, and the 10. That's the distributive property. We're distributing it throughout. Now what happens? Here, we're just putting the A's together, so we're changing this. So we know this is a problem with multiplication, or excuse me, addition. And we've got several things going on down here. Well, we have 4 properties that we can consider. There's the commutative property, and that's when 2 numbers are added and the sum is the same regardless of the order of the numbers. So like 4 plus 2 is equal to 2 plus 4. That's the commutative property. The associative property, when there are parentheses, some numbers can be in the parentheses, some can be out, and you can move it around. So like, for example, 2 plus 3, if I have that in parentheses and then have plus 4, I can also change that and say 2 plus 3 plus 4. That'll be the same thing. That's called the associative property. The additive identity property just says that plus 0 gives me the same number. And the distributive property we saw right here, where you distribute the number throughout the parentheses. Okay, so those are the different properties. And as I see here, all I'm doing is saying, okay, I'm going to move this here, change sides. By changing sides, we're using the commutative property of addition. So that's what goes there. Now, what happens here? Well, I'm just putting these together. Okay, I'm trying to get the 4a and the 20a together. Now, am I adding to both sides? No. So it can't be the addition property of equality. That's when you're doing something to both sides. Okay, is it the associative property of addition? Maybe. Multiplication property of equality? No. Of equality means you're doing it to both sides. And in this case, we're only doing it to one side, just right here. And that falls into where I was talking to you about the associative property of addition, where you can change the parentheses around. But you can always clear out some of the bad ones by saying, hey, nothing's going on over here, so there's no of equality. It's only one side. Two functions, q of x and r of x, are shown. Q of x equals 1.05 raised to the x power. R of x equals 38x plus 125. Both functions have domains of x is greater than 0. So that means x can't be 0 or less. Everything x is bigger than 0. What statement is true about q of x and r of x? Well, let's look. What statement's true? Is q of x always going to be bigger? Well, if I put a 1 right here, anything to the 1 power is itself, so 1.05. If I put a 1 here, I get 38 plus 125, which is, 163, something like that. Q of x is obviously smaller than r of x, so it can't be that. Is r of x always bigger? Well, the answer to that is no. How do I know that so quick? Well, because this is an exponential function, because I have x in the exponent. Exponential functions always grow faster in the long run. They always get bigger over time. So that means q of x will eventually be bigger than r of x, no matter what, because it is an exponential function. So that leaves me here. Q of x is bigger than r of x only for large values of x. Seems that way. R of x is bigger than q of x. No, for a very small number it's bigger, so it can't be that one. So that leaves us with C. Q of x is bigger than r of x, but only for large values of x. So if we start getting 100 into here, it might start getting bigger at that point. So remember, exponential functions may start off much, much smaller than a linear function, but they will always get bigger by the end. Stephen constructs an equilateral triangle inscribed in circle P. His first 3 steps are shown. He creates the radius, PQ. So to look at this one, we're going to sketch a circle. He creates the radius, PQ, using the point Q on the center. So here's the radius right here. From that point to that point, he's going to use the compass to measure that distance right there. So he's going to spread it out so that the point is right here and the pencil is right here on this edge. Using point Q as the center, so he's going to now put the center right here. This is point Q. He's now going to create an arc. Or he's going to measure it and then create an arc. Right there. And then he does the same thing right there. And that will make an equilateral triangle, if it's drawn correctly. So is that what he's doing? He uses point Q as the center and the length PQ as the radius. So this is the center. He extends it. Good. But he uses the compass to construct an arc that intersects at point R. So there's his first arc right there at point R. Using the point R as the center. There's my center. He makes another arc at point S. So there's my triangle. So that's exactly what he's doing. And I know you haven't seen this yet, but if you sketch it, you can try to work your way through it. What should Stephen's next step be? He needs to draw line segments connecting Q, R, and S. Q, R, and S. And that is correct. Okay, point P, R, S. No, P is the center of the circle. That's point circle P. Construct an arc. He doesn't need any more arcs. He's got 3 arcs, so 3 points. Number 16. Some friends spent a total of $12 on popcorn and drinks at the movie theater. The bucket of popcorn costs $2 and a drink costs $1.50. Create an equation to represent the relationship between the number of buckets of popcorn, X, and the number of drinks, Y, that the friends bought for $12. So in A, we're going to look at this and say, okay, they spent $12 altogether. Well, what did they buy? We don't know how many buckets of popcorn they bought, but it was $2 each. So 2X. And again, we don't know how many in drinks, again, for A. We're only looking at A right now. We don't know how many drinks they bought, but it was $1.50 each. So we're saying plus $1.50 for each drink. There's the equation. That's what we need to know. Now B, it says how many drinks, if they bought 4 drinks, how many buckets of popcorn did they buy? So we're going to take our exact equation and instead of Y, we're going to put 4. So now we know how many drinks they bought. They bought 4. What's 4 times 1.5? That's 6. Now we're going to subtract 6 from both sides, so that gets rid of that. And what's 12 minus 6? That would be 6. Now we're dividing both sides by 2. And 6 divided by 2 is 3. So they bought 3 buckets of popcorn. And we don't need the equal X because it's in the question. How many buckets of popcorn did they buy? If I say how many tickets did you buy to the movie theater, you're not going to say 5 equals X tickets. No, you're just going to say 5 tickets. So they bought 3 buckets of popcorn. Number 17. What is the exact perimeter of a parallelogram with the vertices 3, 2, 4, 4, 6, 1? Now you'll notice that you only have 3 vertices. That's okay. All we need are the base and the height, right? or the base or two of the sides, because it's a parallelogram, which means they're going to be the same. So I need to know the distance from here to here, and from here to here, and then we just double those. And so let's go ahead and get started. How do we do the distance formula? It is 3, 2, and 4, 4. We take x minus x, so 4 minus 3, always the big number minus the small number, so 1. 4 minus 2 is 2. We're going to square them and add them. 1 squared plus 2 squared is 5. And so we take the square root of that, and that's one side. So we have the square root of 5 plus the square root of 5 plus, because there's a bottom and a top. So now let's do the other side. It's 4, 4, 6, 1. 6 minus 4 is 2. 4 minus 1 is 3. Squared, squared, plus 2 squared plus 3 squared is 4 plus 9, which is 13. So plus the square root of 13 plus the square root of 13. Now let's use the calculator to figure that out. Don't try to do that in your head. Let's see if we get an exact number. Square root of 5, right arrow, plus the square root of 5, right arrow. The right arrow just makes it so you're done with that radical. Plus the square root of 13, right arrow, plus the square root of 13, right arrow. Oh, I didn't get the plus in there. Plus the square root of 13. And we'll delete that and enter. 11.6832 blah 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 blah. Now we see here that it goes on forever. Well, we don't need that. We can't have that. We can't use a decimal because it's going to round. But one thing we can do is we've got 2 of the square roots of 5 and 2 of the square roots of 13. So when we write it in, we can just say we have 2 square roots of 5 plus 2 square roots of 13. And that's your answer. That's all you have to do. A system of inequalities is shown. So there we have a whole bunch of inequalities. Use the add arrow tool to graph the boundary lines of the system. Drag a star to the coordinate plane to show one solution to the whole system. So let's see what we can graph right now. Okay, we solve both of these for y, so in this case I'm going to add 2x. So that tells me that my first point starts at -9. That's where it crosses the y-intercept. I'm getting that from right here, and we added 2x, so we got y equals, or y is greater than or equal to, I'll just write it down so that we can remember it. Y is greater than or equal to 2x minus 9. And I didn't multiply or divide by any negative, so that stayed right there. So from here, I'm going to go up 2 and over 1. And that would be my line, up 2 over 1. And I'm going to just keep it going so that I have the full line. And then I can easily draw it. Oh, I put that in the wrong spot. So now I've got that. I can easily draw my arrow right here. And I know it's greater than, so it's going to be on that side. And so on my notes, I'm just going to put arrows to say, hey, it's going to go that direction. And you have graph paper if you need it for the test. Now here, I'm going to minus x on both sides, minus x, and then divide by 4. So I have y is greater than or equal to, it stays the same way because I divided by a regular 4, and that's negative 1 divided by 4, the negative 1x divided by 4, plus 6. And if you solve these for y, you'll do just fine. So now we have to add our next point. Our next y-intercept is at 6, and it's going down 1 over 4. Down 1, 1, 2, 3, 4. Down 1, 1, 2, 3. So up 1, 1, 2, 3, 4. Up 1, negative 4. And now we have our arrow. Now it has to be greater than that. So I know it's going to go that way now. Which means that these no longer matter, because it has to be this corner up here so far. Now one more. This one I'll solve over here. We have 6x minus 3y is greater than or equal to negative 9. So I'm going to minus 6x. So minus 6x from both sides. Now I'm going to divide by negative 3. Now be careful, they're always going to throw it at you. What do you do when you divide by negative? You flip the sign. So that becomes positive 2x and positive 3. Okay, back to here. We're going to say, all right, now we're crossing at 3 right here, and it's up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And where does the arrow go? Right there, between those points. And it has to be less than that. So less than. Which now gets rid of this side. So this is where the star is going to go. Right here in the middle. Number 19, which dot plot represents a data set in which the mean is less than the median? Now remember, the mean follows the tail, or it follows the outlier. Okay, so if we have the mean and median in the same spot, then it's perfectly, let's do it up here. Here's my bell curve. If I have the mean and the median in the same spot, that means it's perfectly symmetric. Once I start having a tail, let's say this tail starts going to the left, the mean is going to follow that tail. So in this case, we want a mean that is less than the median. Well, the median's the middle. The mean is going towards the outlier. So that one, the mean is higher than the median. So it can't be that one. Here is the median, middle number, and there's an outlier. So the mean is going to follow the outlier, which means the mean is now lower than the median, or less than the median. So that certainly looks very plausible. Here's the median, and we've got an outlier on either side, so the mean is going to be right there with it. And same thing here. Those are both symmetric. There's no real tail, and therefore that is Yeah, there's no tail, so that is symmetric. Now the reason why I know this one's mostly symmetric, there is a tail, but look at where the tail is. This tail is higher. Like this would actually go like this. So where's the tail? The tail is right here. So the mean is actually moving to the right. So the answer is C. And finally, Julian graphs the function f of x equals 2x squared plus 5, not x squared, equals 2 raised to the x power plus 5. He then moves the graphs down 8 units, creating the function g of x. Create an equation that represents g of x. Well, the y-intercept changed because he moved it down. How far did he move it down? He moved it down 8. So that means that we will have g of x equals 2 raised to the x power, and that's not going to change because we didn't mess with the x. If you change the x, it goes the opposite direction that you might think. As x goes up, then it will move to the left. As x goes down, it will move to the right. But that didn't change. The y changed. He moved it down 8. So what's 5 minus 8? It's negative 3. Oh, we don't want it in the exponent though. Negative 3, just like that. Hopefully this has helped.
It was the most disappointing thing since my son.
The goal is to prepare you for it, to get you ready. Start thinking of these outside of the box a little bit. Hopefully this has been okay and there hasn't been any problems. Please study your notes. Go back through the homework assignments if you still have them. Go back through the tests if you still have them. Especially all the notes that you took or were given in class. Go back through and review them. Remember, please get plenty of sleep right before next class period or the test period, and do your best. No matter, if you get stressed, fine, take a deep breath. Just do the best you can. This doesn't count on your grade, but we really want to see how much you know. So this is an amazing opportunity for you to see how much you've grown this year, and for us to see how much you've grown this year. So if you have any questions, let me know. Otherwise, that's the end of the review.